Um, Let me just give a small overview of where we are coming from. So we've been looking at the concept of probability and some terminologies. We started with the definition of probability. We indicated that it's a number between 1 and 0, right? We also look at some terminologies like random experiment. We look at something like an outcome, specifically a simple outcome. We did look at what is called a sample space, and then we learn how to use diagram, a tree diagram to create a sample space. We also learn about events. We said events are a subset or a portion of the sample space, one or more outcomes of the sample space. Then from there, we started looking at something like some key phrase, like complementary events. We say complementary events usually use like a keyword not. All right. Then we also let me see. We did complementary event. We did conditional. Actually, we did a joint event first. So let me write it down first. We did a joint event. Um, joint event. And then the key phrases A and D. Joint event. And from there, we also did complementary events already. We did conditional. We did conditional probabilities, right? We did conditional probabilities, and in conditional probability, we said the key phrase is given. You'll see that the online assignment that is due tonight, a couple of them have the word given in there. And we said that in conditional probability, if you write probability of A given B, usually the format is the event given the condition. So if it is a cross tabulation table, then the condition restricts. So condition reduces your sample space, because the condition tells you what you should focus on, right? So what group to focus on. So we couple of your homework, you see we also did some problems that help you to understand this. Then we also started looking at mutually exclusive events, and we said that for mutually exclusive event, P of A and B, it's 0. All right, P of A and P of A and B, it's 0. Now note that conditional event, mutually exclusive event, in both situations, there are usually more than one event, right? In the conditional probability, we say that at least one event has already occurred. So usually the condition has already occurred, right? So here, condition has already occurred, or is given. All right, the condition has already occurred or the condition is given. So whatever comes over here is a condition, which usually, and then we read a line as given that. Okay, so these are some key phrases. When you are reading the questions, you have to look for those key phrases. All right, so today we're going to move forward. This is just like a summary of some of the key terminologies that we have looked at early on. All right, so today we are going to um, focus on non-mutually exclusive events. All right, so we are looking at non-mutually exclusive events. Now, so if we have events, we could have mutually exclusive events, means that they cannot overlap. So probability of A and B is 0. Or we could have non-mutually exclusive events. Now, mutually exclusive event means that they cannot occur together. So they cannot occur together. All right. Um, Meaning that they are disjoint. Disjoint. Like if you have a set, this no overlap, or I could say no overlap, no overlapping space. So this A, this is B, nothing in common, nothing in common. Okay, now in the non-mutually exclusive event, this time so let me make a space here. This time the probability of A and B is not equal to 0. All right, it's something that it's greater than 0, not equal to 0. Okay, so in this
Excuse me, your
particular
screen stopped sharing for me. Oh, never mind. It's back up.
okay, are we okay there? All right,
Yes.
all right. So the non-mutually exclusive events, we have P of A and B not equal to 0. P of A and B not equal to 0. So event can be classified as mutually exclusive or non-mutually exclusive. Now, today, one of the things that we are going to learn is that if it is non-mutually exclusive, okay, we can reclassify them into two groups. In other words, when we say A and B and they have some overlap, we could ask ourselves, what is the source of the overlapping, right? So in a non-mutually exclusive event, we have independent event, and then we have dependent event. All right, I'm going to write it out at maybe another side to make it easy for us. Okay, so we have independent events and then we have dependent events. Okay, so if they are not mutually exclusive, then we can classify, we have to further classify it as, are they independent events or are they dependent events? Now, independent event comes in if the result of one does not affect. So let's say one event. So let me just write it here. So independent means that one event does not affect the chances of the other event. One event does not affect the chances of the other event. occurring. You could think about if you have a coin, you flip a coin twice. So flip coin twice. The result of one does not have anything to do with the result of the other, right? So flipping a coin is an example of independent event. All right, the result of one does not affect the result of the other. All right, so one event does not affect. So in independent event, you are thinking about asking yourself, does one result affect the probability or the chances of the other thing occurring? All right, so let's say you and your friend are in this class, and for example, you say, well, today I don't feel like going to class, right? If the coming to class between you and your friends are independent event, you saying you are not coming to class is not going to influence your friend in any way that your friend is also not coming to class. All right, now on the other hand, dependent event dependent event means that the occurrence of one, so here one event occurring affect affect the chances of the other occurring. So let's say you give your friend a ride every time, maybe to class or wherever it is, and you, for whatever it is, let's say your car broke down, right? So then your friend, because your friend depends on you, your chances of maybe coming to class will be affected by your friends coming to class will be affected by whatever is happening to you. So we have independent event and then we have dependent event. All right, so if there's a relationship, we want to check between A and B if they are not mutually exclusive. If they are not mutually exclusive in some way, it means that there is some kind of relationship, right? They both have to appear together, right? If there's a relationship, we want to check if the relationship is independent or the relationship is dependent. Technically, that's what we're trying to say. All right, so but let's first start with an end, right? Probability. We did a little bit of end somewhere. Probability of A and B. So let's take this example that I have here. We want to find probability of female and the person belongs to blood group A. So female, it's all this line. Blood group A, it's all this line. It's all this line. So end means where they intercept, right? The overlap, the overlap, or the intercept, intersection. I want to write intersection. The intersection. All right. So the number of females who have blood type A are 18. All right. So probability of female and blood type A will be 18 over 100. Now, this is a sample space. Sample space. Okay. Now, the fact that these two have a value, it means that this is not zero. If it's not zero, it means that they are not mutually exclusive. Not mutually exclusive. All right? They are not mutually exclusive. Okay. So just like I said, in a non-mutually exclusive situation, the events may be independent or event may be dependent. And I've also explained that if they are independent, then it means one occurrence of one event does not affect the probability or the chances of the event occurring. If they are dependent, then the occurrence of one event affects the probability of the other event occurring. Okay. Now, so suppose I give you a small crosstab table like this, and I ask you the question: events F and G independent? Suppose I just ask you this question: event F and G independent? What do you have to do? In mathematics, in general, for independent event, probability of A and B must give you the probability of them multiplying individually. A times probability of all the A's times the probability of all the B's. So this is a formula I want you to note. All right. I think I missed that on, did I miss that on one of the slides? Let me see here. Oh, okay. I think I put it here. All right. This. Okay. Test for independence. If it says the same, this is the one I definitely want you to remember. P of A and B is equal to P of A times B. And this is only true if the two events are independent. All right. So let me take you through this so you could see what is happening. Now, in this question, though, we are dealing with F and G. So you're going to say you want to check if probability of F and G can give you probability of all the F times probability of all the G. Right? So here I want what I'm doing to be relevant. So I've interchanged the A with F. I've interchanged the B with G. Now, do this portion as if that's the only question you have. F and G. Does F intersect G? Let's see. F goes this way. G goes that way. Where do they overlap? At 8, right? So F and G is 8 over 25. 8 over 25. That is F and G. 8 over 25. Now you want to check whether, so let me put a question mark here. You want to check whether 8 over 25 is the same as the F alone times the G alone, the probability of those things. So F alone is all the F. So when you see like P of F, it means all F's and then all G. All right. So all the F is what? 12. All the F is 12 over 25 times all the G is 15 over 25. 15 over 25. All right, then we could actually play around with this later on. Maybe 5 here, 3 here. So we can get what? We can get 12 times 36 over 125. This is what? 8 over 25. Now, this is not equal to that. If you use your calculator to check, you would see that this is not equal to that. We said that for independent, they have to equal, right? So the question says, are they independent? The answer is no, they are what? Dependent. If they are not independent, then they are dependent. If they are not independent, then they are dependent. So that is how to verify whether two things are independent or dependent if they give you a crosstab table. Okay. Now we can also use independent to answer certain questions, right? Because in each case there is some degree of multiplication going on. So let's look at this question. It says that a jar has three red, actually three red, um, five green, blah blah blah, and the question want us to find green and green and green and red. However, they said that a marble is taken at random from the jar after replacing it a second marble. So anytime they take one marble, right? Let's say the first time there was a total of 16 marbles. Then they replace. So the second time, there's still going to be a total of 16 marbles. All right. And usually means we're going to multiply. So in this case, you're going to ask yourself the first time, what did they select? They select green marbles. All right. How many greens are there? 5 over 16. Then they put it back. They replace it, right? So the total still stays at 16. Then they pick up another marble, yellow marble. How many yellow marbles do we have? We have 6. So that will be times 6 over 16. Okay. Now let's look actually at the same example, but this time dependent. Now, in this example, so they have, let's say the first time before you made a selection, there was a total of 16, but the question said without replacing, so no replacement. So if they take one out and they don't replace, the total will now be left with 15. Okay, so they don't replace, so each time they come and make a selection, the total will be reducing. All right, so in this case the red marble, so that is still oh, green, sorry, green is 5 over 16, then yellow is 6 over 15, because they did not replace, not replacement. All right, so this is second, they didn't replace the second one, and then you work it out from there. Okay, now we've already seen the conditional formula. So the next thing I want us to talk about, it's another concept called the addition rule. The addition rule. Now, addition rule, usually the key phrase that is used is or, O-R, or. Remember, conditional, they usually use given. Complementary, they usually use not. Joints, they usually use and, A and D, right? The addition rule basically deals with combining two or more sets. All right, so here we are combining two or more events. Now, in the olden days, we call that union, and it is like a U up like this. All right, so when you see A union B, is the same as saying A or B. In other words, we combining events A, A, B. We are combining event A, B without repeating, without repeating elements. So let me give you something here. Let's see. So we have this, let's say this event A, this is event B. Let me use another color so we could see the boundaries well. So event B and event A. Now note that where they overlap, like they overlap over here, right? where they overlap, it's A and B, right? A and B. That's where they overlap, is A and B. Now the whole circle is A, the whole circle here is B. So note that circle A includes A and B. Secondly, circle B also includes A and B. So when you combine A and B, you're gonna end up having two of A and B. Why? Because in circle A, you've already taken care of A and B, but then when you add circle B, so if you just did A plus B, that will give us 2 of A and B. All right, it's going to give us 2 of this. So, oh, that's not what I intend to do. So, when you combine, you want to subtract. When you combine, so when we say A or B, when we say A or B, you take all the A's plus all the B's, but because you've done 2 of these, you got to take 1 out. You just need only 1 of it, right? There is only 1 A and B, but in combining, you have 2 of them, so you subtract minus A and B, minus P of A and B. So this is a very important formula. However, note that if the two events are mutually exclusive, remember we did a little bit of mutually exclusive before, the two events do not have any overlap. A, B, there is no A and B because there's no overlap. So then the part that says minus P of A and B goes out because that is 0. So if the two events are mutually exclusive, if A and B are mutually exclusive, then P of A or B is just P of A plus P of B. So the addition rule is extremely important. You got to remember this. You have to remember this. All right. So P of A or B means combine A union B. All right. So it's all the A's plus all the B's minus their overlap. So let's look at an example on the next slide. So in this example, suppose they tell us, they told us that event A has 5 members, 1, 2, 3, 4, 5. Maybe let's take this for lack of better word. Let's say these are labels for certain students, and event B that. So let's say event A are people in the math class, event B are people in the English class, or let's say you have two different friends, sets of friends, A and B. But then take note when we ask to do A or B, the action as to combine A and B, right? Now, you note here that A has 1, 2, 3, 4, 5. B has that. So when you are combining, we take all the A's, which is 1, 2, 3, 4, 5. Then we take all the B's, which is 4, 5, 6, 7, 8. But if you do that, you have, look at 4, 5, 4, 5. They are in both places, right? So you got to subtract the overlap, which is for one of the 4, 5. That's all we're saying. So if these are your friends, I mean, we have 5 here, and then we have another 5 here minus 2. So actually, these are 8 people, not 10 people. All right. So if you want to order pizza for this group of people, you're going to order only 8 pizzas. You're not going to order 10 pizzas, because if you order 10 pizzas, this person, the color is not good for me, so let me change it. So this individual, this individual, and this individual are the same individuals here, right? So you are going to subtract 2 because they've been double counted. Okay, yes, Shaida, go ahead, sir.
Example in the slide, is that incorrect? Because it says A or B includes 4 and 5. And wouldn't that be 4 and 5 be A and B?
Okay, so the key phrase, is we're looking for A or
Or
B.
B? And 4 and 5 is included. Wouldn't 4 and 5 be and instead of or?
Okay, all right. So what we're trying to say, right, that when we say or, you are putting the two groups together without repeating. So when you are putting the two groups together, because we've accounted for 4 and 5 in group A, when you reach group B, you're going to cross them out because they've been counted already. Do you see that? So the overall numbers will be from 1 to 8. They will be, when you combine them, you have to include them in the total group, but you are
Oh,
not double counting them.
all right. I thought you removed them all together and just mentioned, or you would mention 1, 2, 3, and then skip 4 and 5 to go to 6, 7, 8. But
Correct. But mostly when you are doing the problems, one easy way to do the problems is to act as if you are not caring about the repetition, right? So count all the 5 in group A, then group B, 1, 1, 2, 3, 4, 5. Count all the group B of everyone, right? Then come back and check whether you double counted anybody, right? So when you check, you say, oh, I double counted 2 people. All right, so let me subtract 2.
oh, okay. Thank you.
All right, there.
I feel like
So
the visual inside of the circles would help a lot with this specifically.
yes, but you see, a lot of problems will not be given to you this way. Like I'm putting this example because I want you to visually see it. All right, a lot of problems you may not visually see, it might be already in a table, and we'll be doing some problems very soon for you to see.
Okay. Thank you.
Okay, so the general idea is that when you're doing P of A or B, take all the A's, add it to all the B's, and then subtract A and B, which is the place where they overlap, the number of things where they overlap. All right, so let's look at this example. Good. So you've been given a crosstab table. Most of your homework would be in the form of crosstab anyway. So you've been given a crosstab table, and then they told you, well, find the probability that it's male. Then they bring a keyword or type O. So when you see this key phrase or, it means use the addition rule. Addition rule, right? The addition rule comes with a key phrase or. So we are looking for probability of male or type O. Now the formula says that take all the males, add it to all the type O's, and then subtract the overlapping, the end. So M and O. So that is the way you should begin every OR question. Write the formula down. Every OR question, write the formula down. All right. There should always be a plus and then a minus portion. And the minus side is the end. Now, ask yourself all the males, right? All the males is what? 50. So this will be 50 over 100. Now, all the type O, all the type O is 40, right? So plus, so we're gonna do plus 40 over 100. Now, by so doing, you have double counted something. So you're gonna subtract what you've double counted, A and O. A and O is an overlap, so that is 20 over 100. And it makes sense, right? Think about it. When you are adding the males, you included a 20 in the red here. When you are adding the O's, you include, to get this 40, there's a 20 in there. To get this 50, there's that 20 in there, right? So 20 has been counted 2 times. So what you are doing, you are subtracting 1 out. Okay, so now you just work this out to give you your overall answer. So every OR question would require that you do an addition and a subtraction, unless it is mutually exclusive, which we will see it on the next example.
Can you go back up for a second?
Okay, dear.
All right, I'm all good. Thank you.
No problem. So this will be like what, 70 over 100. That's 0.70. All right, so let's look at this question carefully. Now, the question says that type O or, we know the moment we see or, we are dealing with addition rule. Right? Addition rule, we said, comes with a key phrase or. So we saying that probability of O or, I just want to write the order in which they give us, right? So probability of O or, probability of O or A, O or A should give us probability of O plus probability of A, and then check if there is any double counting, probability of O and A. Okay, so let me write the end because it doesn't look too clear. And A. Now, so we're looking O, all the O's are 40, right? When you draw a line like this, all the O's are 40. So this is 40 over 100. Then all the A's is 35 plus 35 over 100. However, they don't overlap. So this is an example. This is an example of mutually exclusive. The last time I was explaining to you that when we write, everything on this line are mutually exclusive because they are non-overlapping. They don't overlap. So if you are in O, you cannot be anywhere else. If you are in A, you cannot be anywhere else. If you are in B, you cannot be in anywhere else. If you are in A, B, you cannot be in anywhere else. All right. So in this case, all you're gonna do is to do the 40 plus 35. That would be what, 75 over 100. So take note of this also. Okay. Now, so these are like just additional examples that you have. Okay, some few important things to note, right? That A and B is the same as B and A, or A or B is the same as B or A. Okay. For conditional probabilities, P of A or B is not the same as P of B. In other words, even B occurring, given even A is not the same as even A occurring, given the condition A. Now note that here the conditions are different, right? This side the condition is B, this side condition is A. That is why they are not the same, because the conditions are different, the events are different. But and or they are interchangeable. Okay. All right, let's look at some more examples. So in this example, one response is selected at random. Find the probability of Miami and. So and always means the intersection, right? And means intersect. Intersect. The intersection of something. Or means addition rule. addition rule. So Miami is this way, yes is this way, where the two lines overlap is 150. So this is 150 over 1000. That's all for that. But when we come to the OR, I need to pull the, actually I could write it here. So, okay. So when they ask me to find probability of Miami or yes, I have to take the probability of all the Miami people plus the probability of all the yeses minus probability of M and Y. I have to do this. All right. So I'm going to ask myself, all the M's, the total of Miami is 250. So this portion, actually, let me write it below it. So this is 250 over 1000 plus all the yes. The yes is 400. 400 over 1000 minus the overlap. I counted something twice whilst doing all the Miami and all the yeses, right? I counted something twice, which is the Miami and yes. So minus 150 over 1000. And then I work for the final answer. Is that 500 over 1000? I don't know. It looks like. So know how all problems comes in. Okay. Now, so some few terminologies, let me mention this in passing. Okay, so when you see the word without with replacement, it means that each time the total do not change. All right, so if a member of the population is replaced after it is picked, then the members being chosen, so members can be chosen more than once, right? Now, usually with replacement, those events are considered to be independent because the total would always remain the same. However, when you see without replacement, anytime the next result, you're going to be one short the other one. All right. And in that particular case, what you will have would be that we will consider those events are dependent. So those events are considered dependent. All right. Dependent is also not independent. So we said independent if the result of one does not affect the occurrence, the chances that the second one would occur, or whatever the result of the second one would be. Dependent when the fact that one event has occurred affects the chances of the other one. Okay. Now, so some formulas I want you to remember. Independent, P of A and B will give you P of A times P of B. For sure, absolutely, 100% remember this. Now, this is important because when you are reading some questions, suppose I give you this question. I say P of A, it's let's say 0.3. P of B, it's for lack of, let me say 0.5. I'm just making it up. And then let me see, okay, that's fine. And let me say that I tell you that A and B are independent. A and B are independent. Then the question says find P of A or B. How do you do this? Start with a question. All right, start with a question. So this is how you're going to approach it. Write a formula. P of A or B is the same as P of all the A's plus P of all the B's minus the overlap P of A and B. Now, P of A in this case happened to be 0.3. let me write in a different. P of A happens to be 0.3. P of B happens to be 0.5. However, they said that A and B, A and B are independent, right? If they are independent, then it means that you're going to do P of A times P of B. The information here, right? So if two events are independent, then these are true. So they haven't given you A and B, but because they said they are independent, this portion is going to be 0.3 times 0.5. So you're gonna have 0.8, because when you add this to that, 0.8 minus 0.15. So 80 minus 15, what would that be? My living calculators, give me some answer. 65?
Yeah.
Excellent. Okay. So take note of a problem like this. In your next test, something like this is always there. All right. However, I can give you the same thing and I can say something like this. P of A is 0.3, P of B is 0.5, A and B are mutually exclusive. I love that word. I don't know why. Exclusive. Okay. Then I say find P of A or B. Now, because they are mutually exclusive, it means that what? P of A, P of A and B, it's 0, right? So when they say find P of A or B, you're going to say P of A or B would just be P of A plus P of B. And when we do minus P of A and B, this side is 0, minus 0, right? So this is 0.3 plus 0.5, and that's 0.8, and that's it. So take note, when the same kind of problems, one they'll say mutually exclusive, the other they would say that they are independent. All right, those are the two types that usually will come in a test. So take note. But I want you to remember these beautiful formulas. Okay, upon that note, I think that I'm going to end. Oh, one more. My time is gone, but one more. You also in your homework be given like scenarios. Like here, it says that A is female having blood type O. We know those are independent, right? Or having a first child, having these two also are independent. But if it's taking aspirin once a day, and then these are related. So when it says dependent, you asking yourself, are they related? And if in here you are asking yourself, they are not related. Okay. So let's just take note. You have some scenarios in your homework, and then you have to just choose whether independent or dependent. Okay. So thank you so much for coming. And
Thank
I
you.
would see you on Friday. Let's all come on Friday. All right. So I wish you all the best. Can I hear your wonderful voices?
Thank you,
Thank
Thank you.
Professor.
Thank you. Have a
Thank
nice
Yeah.
day.
you.
Thank you.
Thank
Have a nice
you. Oh,
Thank
Kali.
you.
Thank you. Jasmine. Thank